lecture we are going to perform static structural analysis on a cantilever beam. So coming to the problem description, what we can do is, see here there is a cantilever beam which is fixed at one end and is free at another end. The length of the cantilever beam is 100 mm and the cross section of the cantilever beam is the rectangular cross section with dimensions of 10 mm by 10 mm. Then a uniform load of 1 MPa has been applied on the top face of this particular cantilever beam, and see, this beam is made up of steel. So what we need to do is we need to find out what are the different stresses that occur inside this particular cantilever beam, and also we are going to find out the value of the deflection that is going to occur inside this particular cantilever beam due to the applied load or pressure load of 1 MPa. To perform linear static structural analysis on a cantilever beam, what I am going to do is I am going to go to the analysis system and going to select static structural and then drag it and drop it on the project schematic. And once I drag it and drop it on the project schematic, the first and foremost thing I need to do is I need to define the engineering data or the material with which the cantilever beam is prepared. So according to the problem specification, what happens, the cantilever beam is made up of steel. By default, for every problem, structural steel is the material that is applied in the Ansys Workbench. So right now what we need to do is we can just continue with that default material, which is nothing but the structural steel material. So in this problem I need not give any engineering data or I need not give any material properties for performing simulation. Then coming to geometry, so one thing is I can create my own geometry in the design modeler, or otherwise I can import the geometry from the existing CAD file. So what I am going to do is I am going to right click on the geometric cell and I am going to go to import geometry, then browse, and I am then going to select the beam STP. So this is the file that I have given you as a downloadable resource. You can just download it and then import it like this. And once you have imported the geometry, the creating geometry or importing the geometry step is also finished. Now what you need to do is you need to open the model inside Ansys Mechanical and then create the meshing and then create the loads, creates the boundary conditions and solve the problem and try to find out the values of deformation as well as the stresses. For that purpose, what I am going to do is I am going to just double click on this model cell. So what happens if I double click on the model cell, the mechanical module inside Ansys Workbench will be opened with the geometric data and the engineering or material data that we have supplied to the static structural system earlier using these two cells. So once the required geometry has been loaded into Ansys Mechanical, the first and foremost thing you need to do is you need to see whether the units are set to the units in which you want to view the results. Right now I want to perform simulation and want to view the results in mm, kg and other sorts of things. So I have selected metric and it is fine. If you don't have the same units set up in your Ansys Mechanical, you can just select it from the existing materials options, units option. Then the next thing you need to do is you need to go to the geometry branch. You need to expand this geometry branch and select the solid body. And here when you select the solid body, what happens, all the details regarding this solid body and what are the properties that I can edit are all shown in this details part of the Ansys Mechanical window. So here if I go to material and I go to assignment, see, by default the structural steel is the material that has been assigned to this particular object. As per the problem specification, I need structural steel to be applied to this cantilever beam, so I don't want to change the material assignment. See here, as I have told you earlier, the stiffness behavior is flexible. So if I change the stiffness behavior to rigid, what happens, even though if I apply the forces, I won't get any deformation or the deformation of the body will be 0. For that purpose, I am going to leave the stiffness behavior to flexible. And then you can also check the dimensions of this particular object by going into the properties and here you can see what is the volume, what is the mass, and this particular mass is going to be calculated depending on the density of this particular structural steel. So if you have given a material without density, it will not be able to calculate the mass, or otherwise it will be showing Ansys Mechanical will be showing some random value. Then you can also, for this particular object, you can also find out the centroid in x, y and z directions, and you can find out the moment of inertia and other sorts of things by accessing to the properties group. And if you go to the bounding box group, you can see the length in the x direction, length in the y direction, length in the z direction. You will be able to understand. See here, this is the global coordinate system. So with respect to these coordinates, these values will be created, or these values will be evaluated and shown to you. So now once we have set the material assignment to structural steel, then what I need to do is, the next thing I need to mesh this particular object. As this is a simple object, what I am going to do is I am just going to right click and on the mesh group, and I am going to just press generate mesh. So what happens is, as this is a very basic geometry, you can directly use whatever the options that are present inside Ansys Mechanical to mesh this particular object. So once we have measured the object, the next step is to provide the loads and boundary conditions and then solve the problem. So we are going to do all these things in the next lecture. Once we have created the mesh, the next step is to give the boundary conditions. So in order to give the boundary conditions, what you need to do is, you need to select the static structural branch from this outline tree. This is known as the outline tree. So when you click here, there is a toolbar at this particular bottom of this toolbars. So this is known as a dynamic toolbar. So what happens if I just change the selection of the group, this particular toolbox will change according to the type of selection you made from the outline tree. So for example, if I am going to select static structural, it is going to change into environment toolbar. If I just select the solution group, it is going to be turning into solution toolbar. This particular toolbar is very much useful in order to apply different types of boundary conditions, as well as different types of boundary conditions, supports and other sorts of things. Then coming to static structural, what I am going to do is, I am going to go to the environment toolbox, and as specified in the problem, we need to fix this end and we need to apply a pressure of 1 MPa on this top surface. So for that purpose, what I am going to do is, I am going to select this static structural and I am going to go to the environment toolbox. And don't worry, there are different types of toolboxes here, and you don't worry about all these toolboxes. As we are going to perform a number of simulations in this particular course, you will be able to learn different options from these toolboxes which are necessary. So for now, we are going to go to the environmental toolbox, and then we are going to select the support, and in the support we need to fix this end. So I am going to select the fixed support from here. So once I select the fixed support from here, I can just rotate this particular object. So in order to rotate this object, you just need to press down the scroll wheel, and then you can just rotate by dragging it. And once I am satisfied with the rotation, I can just select this particular face and I am going to press apply. So see here, there is one toolbar known as the selection toolbar, which is very useful. So for example, if you want to select only faces from the object, you will be selecting this particular option, which is nothing but the face select option. So if you want to say, for example, if I select this particular option and I want to just select this vertex, I will not be able to select the vertex, or I will not be able to select the whole body, or I will not be able to select a single line. So for that purpose, if you want to select lines or edges, you need to go to the edge selection tool, which is present here, and you need to press this button or press that particular option on that particular option, and then see. Now what you are going to do is, you will be able to only select edges or lines. You will not be able to select the bodies, you will not be able to select the vertices, you will not be able to select any faces. Likewise, if you want to select the total body, you can go to the body selection. So depending on the type of selection you are doing, you need to select from this, you need to select options from this toolbar. So here I need to apply fixed support to a face. So what I am going to do, I am going to select the face selection. Then we have clearly fixed this particular beam. So here once you have selected the boundary condition, it is going to be represented in a color. See here. So what happens here, the face is being represented blue in color, and on this graphics window you are able to see that blue color indicates that there is a fixed support on this particular face, and you can get information here, fixed support. Then now what I need to do is I need to apply pressure. So in order to apply pressure, you need to go to the environmental toolbar, and then you go to loads. In the loads drop down menu, you are going to have access to the pressure. In not only pressure, you will be having access to number of options or number of types of loads that you can apply in Ansys Mechanical. So I am going to select pressure. So once I select the pressure, now what I need to do is I need to select this top face. So I have selected this top face. So once I selected this top face, I need to click apply here. So whenever you select for applying a boundary condition, or say for applying a load, you just need to select the face or the entity on which you are going to apply the boundary conditions or supports. And once you have selected that particular entity, that entity may be either point or say line or edge or a total body also. Once you have selected that particular entity, you need to come into the details section and you need to apply, press on apply. Otherwise what happens is you will not be able to apply that particular support to that particular entity. So this particular options can be accessed from details part, in details part from the scope group, and you can have this geometry. So the default scoping method is geometry selection, and we are going to see in the further lectures how we can change this scoping method and what are the different scoping methods available, and where we are going to use different scoping methods rather than selecting a geometry like this. Once you have applied this particular geometry, then you need to define the magnitude. So here the pressure is a vector where it is having a direction as well as it is having a magnitude. So the magnitude here is 1 MPa. So I just have entered 1 MPa. If you don't see the units defined as MPa, one thing is you can go to the units here and you can change the units, or otherwise you can convert the 1 MPa to whatever the units that are being referenced here. So for example, if force unit is being shown as Pascal, you need to change 1 MPa into Pascals, that is you need to multiply 1 into 10 to the power of 6 in order to convert MPa to Pascals. Then see, once I am satisfied with the direction, see this direction is towards the downward direction. So this is the direction in which I want to apply my force, so I don't want to change the direction. So here you can define the direction in 3 different methods. One method is the components method, another one is the vector method, and the other one is the normal method. So for example, if the defined by method is to normal method, what happens? If I select any face, the force will be applied normal to that particular face or perpendicular to that particular face. But if I go and select vector, what happens is I need to define a magnitude here, and once I define the magnitude, I should be manually applying I should be manually selecting the direction. So if I just click here, and then I can select any of the lines, see any of the straight line in order to define the direction, and you can press apply here. So if the option is normal to, it will automatically, whatever the face we are going to select, it is going to place the force normal to that particular face. But if it is in vector, we need to define the direction manually, and we need to define the magnitude. It is 1 MPa. Okay, so 1 MPa. Now the direction is good. But say if I don't like the direction and I want to apply the force in the top direction, what I can do is I can just click on this direction option once again in the details view, and then I am going to just press on this arrows. See here. Likewise, I can just change the direction. Then I can give -1 also. So in order to change the direction of the pressure, and then I can also define it through components. So in components means what happens, these components are based on the global coordinate system. This is the x component, y component, and the z component, and in whatever direction I want, I can give the pressure. So I want the pressure to be applied in the y direction. So what happens, I am going to define 1 MPa in the y component. Now what happens, see the direction is towards the upper side, but we want to apply the pressure to the lower side of this particular object. So what you need to do is you just need to type in -1 MPa so that the angle or so direction of the applied pressure will be changing. So this is how we can apply boundary conditions as well as loads to the cantilever beam. So the next step is to solve the problem and find out the stresses as well as the deflection inside the beam, which we are going to see in the next lecture.